Welcome back. Previously we have discussed in detail various methods that comes under the computational correlation. Let us discuss some various cases that comes under the correlation part. Next one, find the coefficient of correlation between x and y and interpret the results. X is given, y is also given. So if you go through it, you can see that the values given in the x and y doesn't come in terms with each other because one is in decimal and another is in round figures. So whether you can do directly in these values given in the question, yes, you can do directly, but instead if you convert the values to a similar point, your computation will be very easy. So how we are going to bring together all these values to a common scale? Common scale means here decimals are given, you need to remove the decimals. So once you are removing the decimal, sometimes there will be a difference in the values of x and y. So if you can either multiply a certain number with one x, or you can divide any number with y. You can do anything in the computation. If the values in the x and y doesn't come in terms with each other, or if the values of x and y come like this, one is in decimal and other is in round figures, you can change the decimal here by multiplying the x with 10. And if you find that the values in the y is bigger than that value given in the question, you can reduce the value by dividing the values of y with any common number. That is a step that can be adopted in the computation of correlation of coefficient. Remember that concept. So in this case, you can multiply the values of x with 10, and at the same time you can divide the values of y by 5. There is no rule regarding if you are multiplying a set of values in x with some value, so at the same time you need to divide or multiply a certain number with the other category. There is no rule like that. The concept is you are trying to bring together the values of x and y to a similar point. That is the concept. In this case, you need to multiply the values of x with 10. It's okay. Then it will be almost similar to the values of y here, but for the time being they are multiplying the values of y with the 5. Even if you done that step or not, you will get the answer correctly. The thing is that you need to remove the decimals must. So in this case, we are multiplying the value of x with 10 and we are dividing the value of y with 5. Then we get new x and y values. See, the value of x become 12, 11, 19, 18, 10 and 9. And finally 79 means total of x. And similarly in case of y, here it is 15, so 15 has to be divided by 5. Not only 15, all the values in the y has to be divided by 5. So it will be 3, 2, 4, 2, 2 and 1. You need to take the total of y, that is the value given 14. So remember, there is no rule regarding multiplying and dividing both the value series at the same time. The concept is you are trying to bring together the series to almost a common style. So you have already developed x and y. So on the basis of details given, you can easily use any method. Since there is no information regarding which method to be followed, you can choose any method. For the time being, let us go with the first equation. And for the first equation, we need to create another column xy. I hope you know how to find xy. You just multiply x with y. And next you need to make the column, that is x square, and finally y square. Since no method is specified in the question, you can follow any method. That's up to your discretion. You can even follow the shortcut method in this case. And in shortcut method also there are two cases. One on the basis of assumed mean, another is based on actual mean. You can use any method for finding the correlation or coefficient between two variables. So once you have found the x, y, xy, x square and y square, take their totals and substitute those values in the equation are equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x the whole square into root of n sigma y square minus sigma y the whole square. I hope you know this equation. This was the first equation we had been dealt in this module. So by solving using basic mathematical step, you will get an answer 0.67. So there are no other computations or calculation in the question. So let us interpret the result. Here in the question you are asked to interpret. So how you are going to interpret? Since it is a positive value, we can say that there is a good positive correlation between x and y. There is another style for presenting the same interpretation. You can follow any method. Just stick on to the scale which we have discussed previously. Interpret on the basis of that scale only. That will be convenient. Next one. Find the coefficient of correlation between age and playing habit. So you need to study between age and playing habit. Question is given regarding age. Age is not specified. Instead, they have given in the form of class. Another is total number of students that comes under the class. This is known as students. That means total number of students. For conserving the space only, I am shortened the word like that. So total number of students for each age category is given, and players also. Players means regular players that comes under that category. For example, here it is first one 200 means out of 250 there are 200 players that comes under the category of 14.5 to 15.5. So we have just gone through all the details given. The question you are asked to find relationship between age and playing habit. So for correlation concept you need single values in x as well as y. Single values means for the x it will be represented by an individual number. Here 14.5 to 15.5 we can't record like that for the computation. So for solving that it is very easy. Just take the middle value, so you will get the value of x. And regarding y, that is the trickiest part. In the question you are asked to study the relationship between age and playing habit. Age we have solved, and regarding playing habit, in the case it is said that in the first one, out of the age group of 14.5 to 15.5, total number of students are 250, and out of 250 there will be 200 students, playing students or player students. So how we are going to identify the playing habit? So for the time being, the playing habit can be represented in a percentage form. So how we are going to find the percentage? The equation is number of players divided by number of students. Number of players means total number of students in the each class of age. So by using that equation you will get a table like this. Here x and y is already given in the question. In the question means just extracted the first step. Age, here age is given in the class. We took the middle value of each class. That is given in the table 15, 16, 17, 18, 19 and 20. And next one y. Y is obtained by using the equation number of players divided by number of students into 100. So in the case of first one 14.5 to 15.5, there are 200 players out of 250. So the total number of students under that category is 250, and out of 250 there will be 200 players. We don't know exactly how many players, just given 200 players. So we can assume that if you take the percentage that value, you will get the playing habit. So by using that equation, you will get the y value that is already stated in the question: 80, 75, 60, 40, 30 and 15. So once you got x and y, and since there are no specification regarding particular method as has to be followed, you can easily use any method of computation. So for the time being, let us again stick on to dx, or the deviations on the base of assumed mean situation, because in the question there is no specification regarding which case has to be followed. So let us go with assumed mean. Assumed mean means if you take the mean of this one, you will get a value closer to this value. It may be some 16 or 17 or 17.5 or 19. Never take that value. If you are using the assumed mean, any value that is preceding or succeeding the mean of that x. So on the base of that, we have found the value of dx: minus 3, minus 2, minus 1, 0, 1, 2, and the total of that column is 3, minus 3. Likewise, you need to find dy. I hope you know how to find dy. Next one, dx dy. Just multiply the value of dx with the dy, you will get dx dy. Next one, dx square, and finally dy square. Once you found all these columns, you need to take the total of dx, dy, dx dy, dx square and dy square, and just substitute these values in the equation. I hope you know the equation for finding the correlation. You can follow any method. There is no discretion regarding that unless any method is specified in the question. Follow as per the details given in the question. So just substitute the values that are shown in the table to the concerned equation. You will get the value 0.99, and it's in negative. Remember, negative. So you need to interpret it accordingly. Sometimes in the question, the interpretation part will be stated, sometimes it won't be. It's better you interpret all your results. So next one, probable error. So next one, probable error. Probable error of the coefficient of correlation is a statistical measure which measures reliability and dependability of the value of coefficient of correlation. That is, if the probable error is added or subtracted from the coefficient of correlation, it would give two such limits, upper limit as well as lower limit, within which we can reasonably expect the value of coefficient of correlation to vary. Usually, coefficient of correlation is calculated from samples. For different samples drawn from the same population, the coefficient of correlation may vary, but the numerical value of such variations is expected to be less than the probable error. So, it is actually a value that helps in identifying the upper limit and lower limit of a correlation value. For example, you will be using a coefficient of correlation equation and you will get a value of R. So, R you have got a value, and how much is the variation that can be occurred in that particular value. For example, if you got a value R equal to 0.5, so it doesn't mean that always the correlation coefficient will be static or it will always be 0.5. Sometimes due to some mathematical properties it might vary. So you need to identify how far that can be varied. So probable error will help you in identifying the upper limit as well as lower limit. For example, earlier I have mentioned that you got the value of R is 0.5. So probable error of that particular correlation, for example, let the computation of probable error, you got the value of probable error is 0.2. Remember, you have got the correlation value is 0.5 and probable error of that same details is 0.2. So what is the upper and lower limit of that correlated value? Upper value of that correlated value, that is 0.5, is just add 0.2 to 0.5, you will get 0.7. So you have got one limit. And another limit, if you deduct 0.2 from 0.5, you will get 0.3. So the how far the variation occur for that particular value of R is 0.3 and 0.7, and the correlation coefficient will lie anywhere between 0.3 and 0.7 if there exist variations. So that is why you are using probable. For identifying the limit of the correlated value, we are using probable error. So the equation for finding the probable error, PE equal to 0.6745 into 1 minus R square divided by root of n. And remember this part, if you remove 0.6745, you will get 1 minus R square by root n. That part is known as standard error of correlation of coefficient, and it is considered to be the best method for measuring the standard error of coefficient of correlation, because standard error measurement is always better than probable error. For the time being, we will be discussing only the probable error concept, because standard error concept is an advanced case in this area. And so, how are the properties regarding probable error? Earlier I have mentioned the problem aspect of probable error. So the meaning of probable error, why we are finding probable error, and how it is used for identifying the limits. That was the concept which we have been discussing till now. Apart from that, you need to remember the properties regarding the value which you got in case of probable error. So before going into that, R means coefficient of correlation. You know how to find coefficient of correlation. N means number of pairs of observation, that is number of items in X as well as number of items in Y. So interpretation of coefficient of correlation on the basis of probable error. Earlier you have used the equations to find coefficient of correlation, and you know how to interpret the value. In this case, you need to identify correlation of coefficient as well as probable error, because for finding probable error, one of the variable in the equation is R. So in the question, if it is probable error is asked, you need to use the correlation equation, and on the basis of that value only you can identify probable error. So what are the interpretation factors that has to be considered? If the value of R is less than probable error, or in other sense, if the coefficient of correlation is less than its probable error, we can say that the value you have got is not at all significant, because it is against the properties of correlation probable error. Next one, if the R is greater than 6 times the probable error, 6 times means if you have got a probable value for a probable error, if you multiply 6 into probable error value, you will get a value equivalent to the value of correlation. In that case, we can say that there exists a significant correlation between the values. Remember this interpretation, because you need to interpret the cases accordingly. Next one, if the probable error is less than 0.3, you can say that R cannot be considered. And next one, if the probable error is very small or very small, we can say that correlation is existing, but you can't find the limits of that correlation. That means the lower limit and the upper limit. So these are the various interpretations that has to be kept in mind. So during the computation of correlation as well as probable error, you need to remember the scale for R as well as scale for P. And on the basis of that scale only you need to make the interpretation. Interpretation is a crucial part in the correlation and regression area. So just go through the previous cases and questions, familiarize the equations and concepts. We will be discussing about the further cases in the next slide.